want to neutralize, but they can't. They're sterically hindered from neutralizing. So that produces a steady state pH gradient across the bipolar membrane. And so on one side you'll have a lower pH, on one side you'll have a higher pH. So yeah, you get this pH gradient. And then the key thing is you have to poke a hole in that membrane. And if the hole is small enough, I should preface this. Ionomers form little nanoscale tubes through the. If you dump an ionomer into water, the polymer backbone is typically hydrophobic, and the functional groups are hydrophilic. So they'll tend to form tubes through the water, through the plastic when it's just soaked in water. Actually, Jeremy, if you look on Google Scholar, you can probably find pictures of this, or even images. What would it be? Ionomer. Ionomer in water structures maybe is general enough. No, that's not what you should search for that, but okay. Just try Google Images. That'd be the easiest. Yeah, here you go. See, there's a. Oh no, that's polymer crystallization. Let me see if I can find you a picture.
A lot of dentistry stuff, applications for it, for ionomers, I guess.
It's not as easy as work. Dispersants for single. Maybe I can. Capillary structures.
I gotta find a better term to search Google Scholar for.
Here we are. Maybe. Nope. Well, I guess I don't know why that would be hard to find, but we can do that some other time, perhaps. Point is, the functional groups are hydrophilic, and the plastic or the polymer is hydrophobic. So the functional groups all stick out into the water, and they form these little tubes of water that go through this. But those are at like the nanoscale almost, at most like a micron, very, very small. So if you then drill a larger hole, specifically much larger than these holes are nanoscale or barely micron scale, and because of that, they're mesoscopic at most. The mean free path of the water molecules is similar to the diameter of the channel. So that means that the adsorption chemistry on the channel wall will somewhat determine the ion concentration in the liquid. And so at the boundary between the liquid and free space, or if you have a larger body of a reservoir of liquid on one side, you have your tube, and you have your reservoir of liquid on the other side. And so one caveat is that the salt you're working with has to be able to freely exit the tube without too much difficulty. If it binds too strongly to the tube wall, if the adsorption chemistry is too strong, then it'll get stuck in the tube and it just won't come out. So there needs to be ion exchange at the interface between the reservoirs and the inside. But if you have that, then you get this pH gradient through the whole thing. So assuming you have the correct salts and assuming you have the correct ionomers, then this happens. So now if you make a larger hole, which is multiple microns across, 15, 20, 30 microns, maybe even 40, it's large enough that the mean free path of the water is tiny, and generally speaking, the ions will prefer to recombine, and they won't be affected much by the walls of the ionomer. And so you get this flow back of, you get some separation of pH with the small tubes, and with the larger tube, you get a flow back and recombination. And that happens continually, driven by thermal energy, just at one ambient heat path. So that already technically that would make some people uncomfortable in terms of the laws of thermodynamics.
Yeah, it's like a second law violator, right?
Well, yeah, not yet. So if you then put electrodes on the two sides, and they also interact catalytically with the salt solution, basically if they have a different electrode potential, then there's these flowback channels that are cut through the ionomer where an electrical current can flow. And so you have these two things at a different voltage, and you have electrons that can pass through. And so you get this, you get a little bit of a battery-like effect. It's not easy to optimize. That was Dan Sheehan's earlier plan. Nowadays, they're doing something a lot simpler, which I think maybe we should follow their lead in that. But basically, I mean, a lot of people have played around with like joule thief circuits charging lead acid batteries. So if you pulse current, DC current into a lead acid battery, it will look like the lead acid battery is charging more than it actually is. And typically that's because of some changes to the electrodes. Now, Jeremiah mentioned that these things actually do have more power than the input power, which I thought that didn't make sense to me for the longest time, but something new, we found something new recently that suggests that this should be the case. So there's this new thing MIT just put out, and I think a few other papers are published so far, called what was it? The photomolecular effect. Photomolecular effect. And so the idea with the photomolecular effect is just like the photoelectric effect. So if you have a metal with an electron gas, then photons can hit that electron gas, and they can cause an electron to come off of the metal surface.
Ooh, the paper was withdrawn.
Oh, no, already?
Yeah.
Huh.
Well, this one's
23 April 2024. That's weird. But there's a bunch of other papers about it too now. There's a ton of these. Exceeding the thermal limit, yeah. 2023, yeah, there's a bunch of this. So anyway, this photomolecular effect is just the same thing as electrons, but it's with water molecules. So if you have a surface of water and you have photons that come in and they hit the surface, then it's possible to eject a whole water molecule off of that liquid, not due to the standard evaporation, but due to just the light interacting with the water. So let's say you have a UV light and otherwise it's completely dark. So I mean, you turn on your UV light and you turn off your UV light, and your water evaporation rate will change measurably. That's the idea here. So what's interesting about the photo, so basically what I suspect is going on now, so Dan Sheehan's moved on to this other thing. Maybe I should let him talk about it. But I suspect it uses the photomolecular effect. And the interesting thing about the photomolecular effect is it's unexplored so far, for the most part. So the photoelectric effect, the minimum work function for a material that's stable in air is 0.5 electron volts. That's for calcium aluminate electride. which I typed in the chat for you, Jeremy.
I'm gonna search that on.
Hey, Bernie was here. Oops, I missed him.
Electride.
Yeah. Yeah, they're using it on the space station these days. They have they use it for the ion thrusters. But anyway, they just the electrons come off and they neutralize the ions on their way out. So anyway, this stuff has a work function of half an electron volt. That's extremely low. So you can get electrons to boil off of this stuff just by heating it to 300 Celsius, and then already enough of the Boltzmann tail is above 0.5 electron volts, where you get electrons evaporating off of the surface, basically. So that's cool. The photomolecular effect, in principle, you could have you could have interactions much lower than 0.5 electron volts. So that's really exciting, because if you can find a photomolecular effect combination of materials, 2 different liquids, 2 different gases with some interdiffusion coefficients, and the energy associated with the photomolecular effect is like 0.25 of an electron volt or something of that nature, then now you're talking about something that you could basically harvest thermal energy with. So you would have like a boundary between 2 liquids, or some liquids and solids, and you would have a capacitor that self-charges potentially. So that's huge. That's a huge thing. Anyway, I just wanted to mention that. That's this photomolecular effect. There's going to be a ton of applications of this.
Yeah, that's awesome. How is that different than what you talked about with the what we're making this graphitic carbon nitride? And
that's called photocatalytic water splitting. So
photocatalytic water splitting, that's different.
Yeah.
And is that related to what Terrence Howard was talking about with the, he used the frequency of beryllium to split water or whatever?
Not at all. That's so what you're doing here is you have typically a semiconductor particle with a catalytic surface. So molecules adsorb to the surface; they get stuck on the surface, and then it's a semiconductor. So like with those gallium arsenide quantum dots, if you look up gallium arsenide quantum dots, and they all fluoresce, or just quantum dots. That will do. You can make like a rainbow out of them. Do they have?
Sorry, images.
Just go to quantum dots. Maybe they're better. There'll be better pictures if we just search quantum dots. Yeah. So different sizes. You have different fluorescences. But that's the idea. So you have these. Typically, they're a little bit larger than quantum dots, just so that they don't immediately decay and release light. You want to hold that photon. You want to hold that exciton on the particle as long as possible until it interacts with adsorbed chemicals and splits them. So this is basically artificial photosynthesis. That's what this is. And so if you have this semiconductor particle, it can split water. In principle, electrolysis is 70% efficient. In practice, there's a lot of work to be done. Like I think photocatalytic water splitting is like 5 or 10% efficient. But like it's on the same curve as solar cells. But all it is you're adding powder to water, and then you're producing hydrogen gas, which you can separate centrifugally with and then you can just like, so you would need some flashback arresters and things, but all you really got here is like water tanks. So
You're producing Brown's gas, not it's hydrogen and oxygen mixed, right?
Yeah, it's hydrogen and oxygen mixed, but so you'd have to unmix them. So that is one possible danger with something like this, but that's engineerable. So you would unmix the hydrogen, you just let the oxygen outside, and then the hydrogen would just go in some pipeline, like an oil pipeline, back up to where it's required, up to like some energy plant. And then with this sort of method, you could cover a desert in these thingamajigs, and you could pipe the energy thousands of miles away. So this, like solar cells, the reason they haven't coated like the Sahara Desert with solar cells is because of transmission losses. You'd have to transfer that power over electrical power lines to somewhere where it's needed. So if you just have a pipeline with hydrogen in it, then and I mean, carefully designed, I would say, you'd need a lot of flashback arresters for that, and a lot of anti-static. Yikes, you know. Well, actually, no. It's like the Hindenburg. If you were in the hydrogen compartment, there was not enough oxygen to have an explosion. So,
what about mirrors and just capturing the light? Like, I was.
Oh yeah, I mean, and that's actually you can do this and that. So there's solar thermal energy. So you have mirrors and you concentrate the light onto one spot, and then you heat it up to high temperatures, and then you produce steam to power a turbine.
Yeah.
With this technology, you could add the photocatalytic material to something like that, and photocatalytic water splitting up to a point, it works better than so at higher temperature and higher pressure, at least until you lose the semiconducting properties of the material, it will continue to split. So, and it'll split more efficiently too. So now you're producing steam and you're producing hydrogen, so you're getting more gas expansion, and then you can harvest the hydrogen afterwards. But I think that sounds like that sounds a little technically complicated. Ideally, you want something that's scalable and like not overly complicated so that you can scale it well. So I don't know.
So of all the super smart engineers and stuff working on these energy problems, if it was easy enough to just put a bunch of magnets on a wheel and make free energy, would they be spending like this kind of money on this infrastructure?
I mean, technically, Charles Bueller's thing would do the same thing. It's just electrostatic instead of magnetic. But yeah, I mean, you could make like a pinwheel with that, and it would, according to what they're saying, it would just start spinning.
Yeah.
So I don't know. It's a very weird time to be alive. I guess we'll see whether Charles Bueller's thing is legit.
Yeah, and Ashton Forbes. We'll see whether Ashton comes out with the real free energy device, or Terrence Howard or one of these guys.
Indeed.
I mean, I am curious. I'm curious to see if there's a magnetic analog of Charles Bueller's device. Because like the one interesting thing is, Jeremy, we've got like neodymium magnets. Those are very strong. Also, magnets hold their charge a lot easier than electrets. So I'm kind of curious to see if we make a magnetic analog of Charles Bueller's device with the field structures all the same, will that still induce propulsion? We could probably build something like that like tomorrow if we wanted to. I don't know. We'll see. But actually, that would be an interesting test, because that would say that would actually prove that the quantum vacuum is made of electrostatic monopoles, not magnetic monopoles, which I guess is almost a given considering what we know about physics. But I mean, it's really not something that's been probed in an open source way yet. So that's interesting.
Well, did you see Neil Tyson did a response to the Terrence Howard?
No, that's
Will we at least get some laughs?
well, the Dunning-Kruger effect. Yeah, yeah. I feel bad. I should have reached out to Ashton before he fell in with this crowd and.
Yeah, that's just like it's exactly word for word what's happening. What happened with Terrence Howard and all that those people is like exactly what I seen happen with Ashton.
Yeah, in this field, like if you don't start out with enough physics knowledge, you're up a creek without a paddle. And that's just unfortunately how it is. It's just you're not going to know.
Yeah,
it's like in a more general case, like I've been very blessed in my life. I've been able to go to many countries and see what it's like there, But a lot of people, maybe they've never left the United States. Maybe the only thing that they can rely on to know what the outside world is even like is propaganda and news media. Like that's some special hell right there.
Yeah, and
like what do you do? Like, how can you possibly know what's real if you just don't even have the funds to ever take a vacation somewhere?
Understand it to be able to build it, test it, and then apply changes to then see what actually happens to actually get a basis of what you're doing, not just completely clueless and taking someone else's word, right?
Yeah, basically, yeah. It's no, and just yeah, and generally, like, if you start your life and you're already being sold lies by the news media, it's turtles all the way down. Then, I wonder if we're the last, like with AI now. I wonder if we're the last generation to have ground truths.
Yeah, it's crazy. I definitely feel bad for the people that are just getting into a lot of this stuff, and this is like one of the reasons we have to keep this channel and this stuff alive. This is just so, it's like it seems like
splitting water doesn't need any additional electrons. I can verify that I've actually come up with the process with zero electricity in, just a couple of zinc plates and copper wires connecting the water that produced hydrogen nonstop, like at a much slower rate, mind you, but still producing hydrogen without any electrical input. So,
well, that's just galvanic corrosion between the zinc and the copper, though.
Yeah, but it's the basic for building.
I mean, they use zinc and magnesium as ship protecting electrodes. So you'll get a chunk of zinc and magnesium, and you'll put it on the bottom of a boat, and it will prevent the like propeller and other components from corroding into the water over time, because the magnesium gets corroded first.
Yeah, both of them are very soft. I found things like tungsten and silver actually lasts exponentially longer than those metals on the opposite sides.
Oh yeah, for sure.
So I have not been keeping up with the whole green year thing. What happened? What's he doing now with this?
Before we get into that, what was the deal with Ashton Forbes' device? Is that just a magnet motor, standard magnet motor?
Yeah, apparently some people found out another video of it, and they said it was. He's saying it's not the same thing, but other people are saying it's the same other known free energy scam. So
that just looks like magnet gears.
Yeah, he hasn't shown a lot of.
What's on the top of that?
So Ashton did a video on YouTube. Let me just go to his thing and see if I can find the video where he's. So there's a video here where it got a lot of views, and I'm gonna find it real quick. That's the one that had it in it.
Oh.
Yeah. No, not that one. Damn it. I must have went by it already. But he's sharing a lot of our stuff too and using it with kind of like out of context and saying that, you know, I don't know.
Yeah, I mean, that's something to watch out for potentially. I mean,
I don't know where it is.
It's like artificially kind of associating this with all the BS stuff, even though we've taken great pains not to be associated with any. Well, I mean,
yeah, I mean it's out there.
That stuff.
It's not. It's hard because they see alien scientists and they immediately think, "Oh, this is all that BS shit." So it's
right. Well, we'll see how it goes. I mean, we've got enough research going on here that like some of these free energy devices that we're working on. Well, not free energy, like non-equilibrium steady state devices.
This is the same thing he showed, dude.
Some of these magnet motors are pretty interesting, actually. If occasionally you'll see one that is like lensless, and if you see a lensless motor that's properly done, it's actually a switched reluctance motor, where the switched reluctance comes from an array of LC tank circuits that are properly timed. So basically, you have some toroid coil, and when you put current through the toroid coil, you're using up some of the magnetic susceptibility of that ferrite. There's a magnetic field looping around the coil, and everyone's gone except me. It's one of those days. Well, anyway, I'll continue whatever. So is it my show now? Basically, I guess. Huh?
Sorry, my apologies. I was setting up the other Free Energy Friday episode where I have Faraday Research. I got Old Man Builds Nathan. I believe nice. Tim's joining us. Cool. And Beneficent TV, also second channel Benefactors, joining us for a second day. He's been reproducing the POE coil, the Peace on Earth coil by One Stop Energies, Daniel and his wife, the Nunezes. And nice. In his coil, he's been able to get 130% or 137% return through feeding it back over Unity in it. He's going to be doing some more live tests and showing it, as well as Mike and Gerald are also going to be there. I sent the link to Jeremy this morning. I was hoping that he would join. Mike, I need your email, and I hope that you're able to join and come on over for a little bit too, because what you're saying is like the realist of science, of the most applicable, most likely viable free energy sources.
Yeah, ever the connector. I like that about you, Bernie. So, but yeah, before we jump to that, and it sounds like a lot of cool stuff there. One of the things I always see is like if someone gets like 130, 150, 170, up to 200% efficient, typically when it's in that range, it's just someone who is not familiar with power factor corrections for measuring power in electronic circuits. So like you cannot, when you have the phases overlapping in different ways than the standard way, then there's some reactive power in there, not just the real power. And the reactive power never.
Mr. Boyd, I meant to send it to Boyd too, but here he is on this one, even better. And
so, but yeah, I mean, so one thing to look out for is reactive power in those circuits. But before we, hey, we have more people. Nice. Hey there. So yeah, Jeremy, I was telling people like with these magnet motors, there's one case where it is interesting. Let me see if I can actually find the video to go along with what I saw. Let's see. Lensless motors. Let's see if we can find a real one.
Guy passed away on Tuesday.
Yeah. I'll move on from this. Anyone? I invited Ashton to come on.
Welcome, Ashton's on traveling to the Cosmic Summit convention right now, so he's not able. Welcome, Mr. Boyd. And if y'all don't mind, in like 5-10 minutes, if we could shut this down and just all hop over to the link in the private chat.
Yeah, no problem. I'll be
Yeah.
joining up with you in a little bit over there. I was gonna shut this down soon anyway, because I gotta get going. But I'll try to join up with you in like maybe an hour or so.
Yeah, for sure.
All right.
We'll be going for a bit. Mr. Boyd, when this does end, in your private chat, I posted the link to hop over to the other free energy stream that we'll
Well, this went really good. I don't want to keep it going much longer than an hour. We're almost there now. I know Michael my boy Mike Boyd just joined.
I didn't know how long you guys were going to be going. So
Yeah, no.
it is what it is.
Good to see
Yeah,
you.
no, but we killed it on a whole bunch of cutting edge science on what people should look into if they really want to do the research into this and be part of this field and push it forward and not get sucked into, stuff that's just going to discredit us.
Well, the over unity part caught my attention because
Oh yeah. Well, so if you're curious,
that perpetual motion, and that's a red flag.
right? Well,
Yeah.
it's not. It's a non-equilibrium steady state. It's not perpetual motion. Once you suck out all of the thermal energy, you're back to just the ground state.
Well, my idea of over unity is you get more power out than you put in.
Okay. Well, that's.
So
Really?
yeah, you can probably do that for a short time, but there's it has Basically, everything equals out in the end.
Right. So anyway, lensless coils. Real quick thing. I don't know. Unfortunately, I can't find the video again right now. But if you have a toroid with a coil around the torus, and you have a number of these around some magnets in your rotor, so that you have these as a stator, you've got a bunch of toroid coils. If you excite the toroid coils, the magnetic susceptibility of that toroid coil to external fields goes down. So you have a switched reluctance motor, and if you have all of these coils hooked up to LC tank circuits, then they're not using any of their own power. So they're just a tank circuit. You're going to have a little bit of resistance in the tank circuit, but you're going to be changing the magnetic susceptibility by a large amount. And so this magnet comes around the loop, and it gets more or less attracted to different magnets, and it keeps spinning around. And that energy, that's an interesting question about, like, is that producing some overunity? But
isn't that just a hysteresis effect that you're talking about, which is it's a magnetic hysteresis? So
you have the magnetic
for a certain amount of time, it's over unity, but then it goes the other way.
Quite possibly.
It depends on where you're looking at it in the hysteresis curve. You follow?
Right. Well, so the hysteresis curve has some area under the curve, but you could use a super paramagnetic material, and then you have minimal area under that curve, and most of your losses are just in the resistance in the wires. But what's interesting is, okay, so if you have, let's just say you have two magnets, and they're toroid coils, so they don't have external magnetic field. So what happens if you set up these two tank circuits so that they're 90 degrees out of phase, and you put a magnet in between them? It's going to vibrate back and forth between these two. But, well, I guess maybe there's the hysteresis is nonlinear, so you're going to change the energy in the tank circuits somewhat based on the position of the magnet in between them.
And then one tank circuit's going to be the opposite polarity of the other tank circuit.
No, the tank circuits are toroid coils, so they don't have external magnetic field beyond, like, it's a loop of magnetic field inside.
There's a crosstalk between the two, correct?
Barely. There's almost no mutual inductance. So if you assume each is a pretty good toroid coil, then the vast majority of the magnetic field is inside the toroid. But if you have another magnet outside, then the force on that magnet will depend on the magnetic susceptibility of the two coils. But the effective susceptibility will change when when each of the toroids is magnetized. But anyway, yeah, that might still be.
Is that your idea? Or is that someone else's idea that we can look up?
Well, I just saw people doing that with lensless motors, and I was like, that's interesting.
Okay.
But I'm sure other people have thought of that.
Interesting. Well, I got to wrap.
Well, I mean, it's just a parametric effect, really. It's like we've been talking about with the, like, but yeah, I mean, the switched reluctance motor is a common type of motor, right? But if you have these toroids and they're just tank circuits, they're wasting like no power changing their susceptibility. So then you just have to time them, each of the tank circuits, to switch at the right time. And you've got a switched reluctance motor where you're not using power to change the reluctance.
Okay, can
Or
we
you're
go?
minimally using power.
There's another discussion that's starting up right now, correct? And that's what this link is for, the other link that you have in the chat?
Yes, sir, Mr. Boyd. Please use it and come on over. We got Tim Ventura, Mike Faraday, Gerald, Phil Bouchard, Benefactor, and a few others. So it's going to be
what the heck, I'll stop by, sure.
Please do.
Okay.
You still got to send us some
So
oranges.
I pulled it up, and I'll sign off this one so you guys can be in your hour. But sorry I missed.
Oh, no worries. We'll be starting right away on the other. Much love, and
Okay.
thanks for having me. Look forward to seeing you all there.
All right, we're going to be talking about this and other awesome stuff. But we'll move everything over there, man. All right.
Okay,
Sounds
have a good night.
Much love, guys.
Water burning hybrid. Oh, this is cool. Water burning cars. These are always interesting.
I got a hold of this guy. This video is 14 years old. He messaged me back today on YouTube. So he said he's doing an update, and hopefully we'll get him on. And
Nice.
also talked to my mechanic. He's getting a car with a carburetor, so we can try rebuilding it too.
Oh, Jeremy, do you still have that NASA paper where they're like electric discharge produces more than the chemical energy input?
Yeah, that should be in the stream from the Terrence Howard night. It should be posting the links in the info on that stream. I'll email it over to you.
Arc liberated chemical energy exceeds electrical output. I've got it here.
Yep. Awesome.
Yeah, that one.
That was
an
cool.
interesting paper. That's also probably relating to some parametric behavior. So the thing with parametric stuff is, I've heard this term with Tom Bearden and some other folks of like regauging. So what is regauging? So you're changing your gauge fields in some way that the real power in the system has now changed. What might that look like? So in space,
you mentioned like you're switching your permeability and permittivity.
Yeah. So if you have a material and you change the impedance of that material with respect to time instead of space, then if you have a traveling wave through that material, then you'll have a reflected wave from that, and the reflected wave plus the transmitted wave has greater than the original wave's energy in general, if the impedance is different. So that's interesting.
We'll leave it at that.
Yep.
All right. Have a good night, everyone. Thanks for watching.
Yeah, Friedrich Morgenthaler's paper was the guy for that. Velocity modulation of electromagnetic waves. He didn't want to talk about impedance, but his work implied that. Anyway, yeah, have a good night.
Well, we will bring it over to the other stream, and I'll check it out. Oh, all right. He posted a link. Awesome. We'll check it out.
Cool.
All right. Thanks. Cool.
Have a great day.
Have a great night.